All right, welcome to this video on electric charge and electric field. There are only two types of charges. One is positive, the other is negative. And we know that like charges repel while unlike charges attract. So if it's a positive charge, it will repel a positive charge. If it's a negative charge and a positive charge, they will attract each other. Now, the basic unit of charge is the charge of an electron, which is 1.60 times 10 to the negative 19 coulomb, and all other charges are integral multiples of the electronic charge. That means you can only find charges that are multiples of the electron's charge. And of course, the unit of charge is coulomb. Now we know that all atoms are neutral because they contain equal number of protons and electrons. But if we remove an electron, it becomes positively charged. If we add an electron, it becomes negatively charged. So basically, charging is adding or removing electrons. Now when this child slides down, because of friction, electrons are transferred, and that involves charging. But remember that whatever number of electrons is lost by an object is gained by the other. The object that loses electrons becomes positively charged, and the one that gains electrons becomes negatively charged. Now there are three types of materials: conductors, insulators, and semiconductors. In a conductor, charges or electrons are free to move within it. But in an insulator, they can move very little. But in biological systems, ions are responsible for the movement of charges. Ions are atoms that have lost or gained electrons. Again, if an atom loses an electron, it becomes positively charged, and if it gains electron, it becomes negatively charged. According to Coulomb's law, the force between any two charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. That means if the two charges are bigger, then the force between them is bigger. But if you increase the distance between them, then the force decreases according to the square of the distance. Which means if you double the distance, then the force drops to 1/4. You triple the distance, the force becomes 1/9 of the original force. Remember, K is a constant, which is 8.99 times 10 to the 9. So that's an important constant. The diagram clearly shows that there is repulsion between the two negative charges while attraction between the two opposite charges. Electric field is an important concept. Any charge produces an electric field in the space around it. And if another charge is kept in that space, the charge is able to exert a force on the other one. Remember that the net electric field due to two or more charges is the vector sum of the individual forces. So you got to take each force and then look at the vector sum of them. The electric field is represented by lines, and if it's a positive charge, the electric lines go away. If it's a negative charge, it comes towards. And if the charge is bigger, then there are more lines, as you can see. So if you have a charged combination of two similar charges, then the field lines are repelled, going away. But if it's opposite charges, then the lines go from the positive to the negative. And inside a charged conductor, there is no electric field. Now let's do some multiple choice questions. Here is the first one. You have a hydrogen nucleus situated to the left of a carbon nucleus. One has a charge plus E, the other is charge plus 6E. And you're asked to compare the forces between the two. So we'll give you a few more seconds to look at the answer choices and get to the answer. The charges are not equal. One is plus E, the charge of the electron. The other has a charge 6 times E. So I hope you picked your answer by now. All right. Remember that whatever be the magnitude of the two charges, the forces between them are equal. So in this case, both are positive, so they will be repelling each other. But the forces on each of them will be the same. So the answer is going to be D. Because D says the electrical force experienced by the hydrogen nucleus is to the left and the magnitude is equal to the force exerted on the carbon nucleus to the right. Here's the second question. So you have 4 point charges, all of equal magnitude and sign, arranged on the 3 corners of the square as shown. What is the direction of the net force acting on the charge at the upper right hand corner of the square? So actually you have 4 point charges, all plus Q. Is it A, B, C, or D? What represents the direction of the net force on that charge at the upper right hand corner? That is the question. Well, I hope you got your answer by now. We got to take the vector sum of the forces. Remember that each charge pushes on the other one along the line joining them. So we would have 3 forces in this case. And the net sum or the vector sum of all of those forces would be along D. Number 3. An electron is initially moving to the right when it enters a uniform electric field directed upwards as shown in the figure. So you see the arrows show the electric field upwards. It's a uniform electric field. And the electron enters. What's the direction of the force? Well, the direction of the force on an electron, because it's negative, is always opposite to the direction of the field. Therefore, the answer is Z, opposite to the direction of the field, because it's a negative charge. If it's a positive charge, it would be along the direction of the field. Then it would have been along Y. So a plastic rod is charged up by rubbing it with a wool cloth, and it's brought to an initially neutral metal sphere that is insulated. It's allowed to touch the sphere for a few seconds and then is separated from the sphere. What happens after it is separated? Remember that the plastic rod loses electrons, becomes positive, and when you touch the metal sphere, a few of the electrons from that part move to the plastic rod, making that part of the sphere positive. So now, there is surely going to be a repulsion because the plastic rod is positive and that part of the sphere where you touched it is also positive. So there is going to be repulsion. Therefore, the answer to this question is B, is repelled by the sphere. Alright, so that will take some time to understand. So here is the next one. The figure shows two unequal charges, plus little q and minus caps q. Okay? And point X is midway between the charges. In what section of the line will there be a point where the resultant electric field is zero? In this case, the answer is going to be nearer to the small charge. So it will be in the region VW, because if you have a charge just to the left side of that small charge, because it's a positive, it's going to repel it, and the other big charge Q is far away, but it's going to be able to attract it with an equal force, thus cancelling it. Okay, but if the charge is at Z, then it's closer to a bigger charge and further away from a smaller charge. Therefore, those two forces cannot cancel out. Now, X and Y are two initially uncharged metal spheres on insulating stands, and they are in contact with each other. Now, a positively charged rod R is brought close to X as shown, and then we have to find out the nature of the charges on the two spheres, X and Y. So initially X and Y are touching, so when you bring that positively charged rod, X is going to become negative, Y is going to become positive, because the electrons are going to move from Y to X. So when you separate them, X is negative, Y is positive, because the electrons from Y moved to X, and now you separated them. So there is no chance for the electrons to go back. So X is negative, Y is positive. Brings us to the next one. Which of one of the arrows shown in the figure best represents the direction of the electric field between the two uniformly charged metal plates? Alright, electric field is always from positive to negative. So that one is easy. Electric field is always from positive to negative, because electric field shows the direction which a free positive charge would move. And therefore the answer is A. It's from the positive plate to the negative plate. That is the direction of the electric field all the time. Which brings us to question number 8. An electron and a proton are released simultaneously from rest and start moving toward each other due to their electrostatic attraction with no other forces present. Which one of the following statements is true just before they're about to collide? So remember, it's an electron and a proton. They have the same charge, but their masses are not the same. Now, what about the force between them? Remember that the force between them will be the same. So the force is the same, the masses are not the same, and acceleration is force by mass, isn't it? Force by mass. So the bigger mass will have a smaller acceleration. So the proton will have a smaller acceleration. There is the answer. They are closer to the initial position of the proton than to the initial position of the electron. Why? Because the proton has a smaller acceleration. It doesn't move that much. So the electron would have moved a lot more. Number 9. So you have 2 point charges Q1 and Q2 separated by a distance r. The magnitude of both the charges are made half, and their separation is also made half. What happens to the electric force? When you make both the charges half, the force between them becomes 1/4. But then when you bring them closer, you made the distance half, the force between them increased 4 times. So when the two charges were each made half, the force decreased 4 times. But when you halve the distance, the force on that increased 4 times. That means it cancelled out, it remains the same. The force does not change, because on one hand it increased 4 times, and on the other hand it decreased 4 times, which means it is the same. So number 10, there are two stationary point charges, Q1 and Q2, as shown in the figure, and the field lines are also shown. What can you deduce from the sketch? So look at it carefully. Q2, you have a higher density of lines around Q2, the top charge. So that means Q2 is of a bigger magnitude, while Q1, the lines are more separated, so Q1 is a smaller charge. But again, when you see the diagram, you will see that the lines are coming towards Q1, so Q1 is a negative charge, while the lines are going away from Q2, so Q2 is a positive charge. So Q2 is bigger and positive, Q1 is smaller and negative. Therefore, the answer is B. Q1 is negative, Q2 is positive. The magnitude of Q1 is less than the magnitude of Q2.